Welcome to Light O'Clock. Today is the 25th of March, 2025, and in just a few days, on Sunday, the 30th of March, clocks across Europe will jump forward by an hour as we switch from standard time to daylight saving time. Many of you might be looking forward to later sunsets and more evening activities, just like Teresa, who shared her excitement with us around this time last year.
Hello, this is Teresa calling in from Glasgow, Scotland, just as the sun is setting at 7:30 and feeling super excited about the change of the clock, partly just because it means later sunsets, but also really looking forward to sleeping in a little bit more tomorrow morning because my cat won't be getting up quite so early to ask for breakfast with the sunrise.
But what you may not realize is that this shift to daylight saving time, which we will shorten to DST, just to make things a little bit easier, is a hot topic, actually, in the world of sleep and circadian science. Many experts actually argue that DST is harmful to our health and should be abolished. At the same time, though, research studies on this topic present mixed results. And the issue is also deeply political. So, in this episode, we'll tackle three key questions. First, why do many chronobiologists want to get rid of DST? Second, what does the evidence say about the impact of DST on road traffic accidents? Third, what does the public actually think about this clock change? Let's dive in.
What we're talking about is a policy practice that impacts on billions of people. So it's something that we would like to get right. What right is now is a different question.
Let's start with the basics. We all have an internal biological clock, the circadian clock, which runs on a roughly 24-hour cycle. This clock synchronizes to the environmental light and dark cycle by light exposure, so basically to the day and night cycle. So light exposure is really the main signal that tells our brain what time it is. And in this episode, we will call this environmental light signal the sun clock, in contrast to the social clock, which is the local time that you have on your watch, your laptop, your smartphone, and so on. This social clock is just a human approximation of the sun clock. This is because to represent the actual clock time, we have adopted time zones, which are defined by meridians, which are these longitude lines which kind of cut the Earth in apple slices, if you want. If you live directly on an hour meridian, say that you live in Greenwich, near London, where the prime meridian runs, then your sun clock and the actual clock are the same. But if you live at the very west of the same time zone, say that you live in Lisbon, for example, the position of the sun in the sky will be different than what you get in London, right? Which basically means that your sun clock will be different than the sun clock of your friends, for example, who live in London. Yet, if you look at your watch, it will say exactly the same time as the one in London, because Lisbon and London are in the same time zone, right? And so the social clocks are the same, even if the sun clock is not. Now you might think, cool, fun fact, but what does this have to do with the clock change to daylight saving times that we're talking about in this episode? Well, basically, when we switch to DST in the spring, what we're doing is that we are changing time zones without really going anywhere.
When we switch to daylight saving time, what happens?
This is Sara Montagnese, medical doctor and chronobiologist in Padova, Italy, and Surrey, UK.
So say, we've said it before, I live in Padova. So I move my watch as if I were going to Istanbul. So I move one time zone east. Except I do not actually go to Istanbul, because if I went to Istanbul, what would happen is I would slowly, or not so slowly, synchronize to the light-dark cues in Istanbul. So when we switch to DST, I keep living in Padova. My eye and my brain receive light-dark signals as of Padova, but my watch says Istanbul time. The immediate consequence of this, the simplest, is that I do not really sleep and I'm not really active at the right time from the point of view of my clock. And my clock plays a very important role in sleep-wake regulation.
Okay, so you're kind of jet-lagged a little bit, right? So you're a different time zone, but actually you didn't move.
Yeah, so you are, that's absolutely correct. So you're jet-lagged, but travel jet lag, you are jet lagged until you give yourself the time to enter into local light and dark cues, which doesn't happen at all with DST because you've gone nowhere.
So what are the consequences of this shift? Well, scientists say that we have acute consequences. So these are consequences that are immediate, happening just after a clock change. So say, the Monday, Tuesday, Wednesday after the clock change. And then we also have long-term consequences. So these are consequences on our health that extend beyond the few days after the change. Here is Till Roenneberg, professor of chronobiology in Munich, explaining this.
There are potentially two consequences. One is the acute consequence, and that has been the consequence that has been looked at most intensely. So the day, or the Monday in most cases, the Monday after they've changed the clocks, we basically start the day an hour earlier than we used to. And whenever we do that, you are prone to have more accidents, more mistakes, more cardiovascular happenings, emergencies, and so forth. Because you already, every Monday, you have more than on a Tuesday, Wednesday, or Thursday, because we come out of the weekend and we suddenly have to get up earlier. So getting up earlier by itself has consequences, and most people have focused on these consequences. But I would argue that the short-term consequences of having to get up an hour earlier are not as severe as the consequences living in an environment where you have to get up an hour earlier for 8 months.
Okay, so the immediate consequence is that we lose an hour of sleep and have shorter sleep duration. We also have worse performance and more accidents, and generally worse health. For example, there are more heart attacks during this time than other weeks, and visits to the emergency room also increase around this time. But what about these long-term consequences? Well, you have to think that our biological clock, as we said, adapts to the light and dark environment. And this synchrony between the body clock and the sun clock is vital for our health. Now, the thing is that with DST, we might change the social clock, but we do not change the sun clock. We can't possibly change the sun clock. And so we have a misalignment between our biological clock and the social time, which we call social jet lag.
The discrepancy between what the biological clock wants and what society wants, I once called social jet lag, because it is like jet lag, like living internally in the wrong time zone without ever traveling. So basically what DST boils down to is that there is a decision from basically the politics to start working an hour earlier. It's nothing else but that. It's not that clocks are changed. For the biology, clocks don't change. They stay the same as they are. They disregard whatever is on the dial of a clock. So what happens is that nowadays clocks, most biological clocks, are already very late. 85% of the population needs an alarm clock to wake up in time to go to school or work. And that already shows you how late they are. And now comes DST. And we are already late to be ready for school, let's say, at 8 o'clock in the morning. And now we are supposed to go to school at 7 o'clock in the morning. Nobody notices that because they changed the clocks and it now says 8 o'clock when it actually is 7 o'clock. But we have to go for 8 months, we have to go to school at 7 o'clock in the morning. And that is the background where we can start thinking about why could this be not so good for us.
Right. So basically, the long-term consequence of DST is that it leads to higher social jet lag. And social jet lag has been associated with a range of negative health outcomes, like higher risk of metabolic disorders, increased incidence of depression, greater likelihood of heart disease, and so on. The thing is, though, that the long-term effects of DST are really hard to study. This research is really challenging because throughout the DST month, so from April to October, there are so many other changes that occur that might influence these outcomes. So, for example, changes in weather, changes in day length, so the position of the sun in the sky will change. Also, the activities of people actually change quite a bit throughout the year. So this complexity makes it a little bit difficult to directly compare DST with standard time, which is the time that we have between October and March, and draw clear conclusions about their differences in terms of social jet lag and other consequences. One example of research field where we can really appreciate how hard it is to answer the question, is DST better or worse than standard time, is when we're looking at road traffic accidents. And this is a good segue to our question number 2. What does the evidence say about DST and road traffic accidents? So, one concern is that DST contributes to more road traffic accidents. And research has explored whether accident rates increase during the DST months, April to October, compared to standard time months, November to March. I spoke to Sara, who you've met at the beginning of this episode, about this, because with her colleagues, she looked at whether DST negatively affects driving performance. And she did a pretty cool study to look into this.
We got together with a very nice group of transportation engineers with whom we perform a set of simulator studies. So you put people in a driving simulator. They have really nice ones. And we showed that prospectively. So we did the studies across the change. And the last study we did for many months into DST. And we were able to show that driving performance, both on a commuting route and on a motorway, so simulating fatigue and somnolence, was considerably worsened after DST, which was a bit surprising because we thought the second time you sit in the simulator, you're bound to do a bit better because you've familiarized with the system. And despite this, we showed pretty big effects. And when we did the fatigue experiment long into the summer, we were also able to show that these effects last. And interestingly, some of the effects were more prominent in people with an evening preference and some with a morning preference, because of course, also depending when you do the experiment, people are out of sync either way. So evening people maybe will suffer the morning commute and morning people will suffer the long drive in the afternoon. So it's a complicated but fascinating matter.
So just to make sure that I understand what you did, you put people in the simulator in the days before the change to DST, and then afterwards, and then you compare the results.
Always the same time, clock time, always the same day of the week, always the same. We tried to be as consistent as we possibly could, and people were actually very compliant and very good at playing with us.
That's a really cool experiment. The few papers that have looked into this, in fact, do show that DST negatively affects driving performance and also fatigue, with drivers showing slower reaction times at intersections or more overtaking violations, for example. But worse driving performance does not necessarily mean more traffic accidents. And so later on, Sara and her colleagues started looking into the available evidence for the effect of DST on road traffic accidents. They used this method called the Delphi panel, which is a structured way to analyze expert opinions.
A small group of experts is chosen, and then a group of experts, which is called the Delphi panel, is also chosen. So the small group of experts produces 5, 6, 10 relevant questions to be answered in the field. These are sent to the Delphi panel, which approves or modifies the questions. Then the experts attempt by a very formal, structured process of literature review. So all the papers included have to have certain features and have to be analyzed in a certain way. And they try to draw conclusions on each of the questions. These conclusions go back to the Delphi panel. And depending on how many people within the Delphi panel say, yes, no, I want this changed, they become more or less strong or accepted recommendations. So it's an iterative but important process that leads to medical guidelines.
Sara and her colleagues used this Delphi panel approach during a workshop at the University of Surrey, where the idea was really to try this approach out and understand whether there are more road traffic accidents during the DST months compared to the standard time months. They searched for studies that had previously been done that had quantified the number of accidents around the time of DST.
So we found 31 papers that we could include in the evaluation. We split them by depending on whether they looked at short-term effects, which we call 2 weeks, or longer term effects, which were up to 13 weeks. We only kept papers that had data, although several of these papers also tried to model the data and make projections within longer times, and that we analyzed. So say a paper had data for 2 weeks, but they made a model to also assess the following 4 or the following 6.
I see. So basically, when you say like 2 weeks short term, it would be, okay, they look at the effect of DST on road traffic accidents in the 2 weeks after DST.
Generally by comparison with the 2 weeks before.
Okay. And were these studies easy to compare between each other? Because I can imagine that when you're trying to assess evidence, right, you want the studies to be as similar as possible. So how were they designed? Were they quite similar in terms of how they assessed this impact?
Well, they were all retrospective studies on different national, international road traffic safety data sets. The heterogeneity was related to the way they were analyzed, the length of time of the analysis, and geography. They came from very different places in the world, which when we then looked at the results, we thought might have impacted considerably.
Yeah, can you tell us a bit more about why that is?
So when you look at road traffic accidents, you're looking at a phenomenon which is incredibly complicated. So driving performance is obviously important, but environmental lighting is probably equal or in some instances even more important. So if driving performance worsens, say, after DST, but depending on where you are, lighting in the environment increases considerably around about commuting time when people come back from work in the evening, the effects could obviously very easily cancel out. Also, during DST, and if you compare the non-DST months, the weather changes. Especially, some studies were performed in countries where there is very bad weather in the winter. So the level of confounding is phenomenal. And also, the interesting thing was that we had a traffic engineer helping us out analyzing the data. And to him, it was all very obvious, things that chronobiologists wouldn't think about, because, of course, depending on traffic volume and type of traffic in each country at any given time, you can see very, very different results.
This goes back to what we were saying earlier, disentangling the effect of DST from the effect of lighting, changes in daylight across seasons, geographical location. It's really, really hard. And so it's not surprising that when Sara and her colleagues looked at the evidence, it was very mixed.
In both instances, long and short studies, and at both ends, spring and autumn, there were studies showing worsening, improvement, and many studies showing nothing.
Okay.
So no difference. So what we learned is that it is a lot more complicated than we thought to begin with, and that our perspective is possibly only one perspective.
Right. Yeah. So if all of this evidence is all of these studies had very different results, then it's also hard for the Delphi panel to come up with a conclusion, right? Or rather with a a recommendation.
Sure. And in fact, the Delphi panel didn't produce a statement or a recommendation on this. The concept that from a physiopathological and the health point of view, DST is bad for human being remains a fact. But whether it translates in increased road traffic accidents really remains to be demonstrated.
Okay, so we have heard why from circadian rhythm, sleep perspective, DST is a bad idea. We have also heard about the challenges of studying the effects of DST on health outcomes. But there is still one big question that we want to address. What does the general public think about clock changes? Do they want to abolish them? And what system would people want to adopt if we really abolish the clock changes? I spoke to Andrew Coogan from Maynooth University in Ireland about this.
So it's an interesting question. It affects everyone. And I think this is why it's a really interesting and important topic, because what we're talking about is a policy practice that impacts on billions of people. So if we think about sort of potential health impacts of changing or not changing the clocks, even if those impacts are small, maybe raising the risk of heart attacks by 1 or 2%, once you multiply that up, across billions of people, the public health, the absolute amount of public health impact can be very large, because it basically affects everyone in those societies that are doing the clock change.
Yeah.
So it's something that we would like to get right. What right is now is a different question.
You've explored public opinions on the matter of clock changes. So while we know that this is a controversial topic, so the clock changes are controversial in the field of circadian science, sleep science, you wanted to find out, okay, what does the public actually think about this?
Yeah.
Why were you interested in this, and why did you think it was important?
So in 2018, the European Commission did a public consultation on whether they should move towards abolishing the clock change. Unfortunately, that consultation had a very low response rate. And as we learn in sort of research methods 101, to do with surveys, if you have a low response rate, you have a high risk of what we call non-responder bias. So you tend to get the opinions of people who have very strong opinions one way or the other. And then when I sort of looked into it a little more, I was quite surprised that there wasn't more scientific evidence on sort of public perceptions of clock changes. And I think when we talk about that, there's two questions, and they're linked. There's one, should we get rid of the twice yearly clock change? And then the following question is, if we do, well, what configuration do we revert to? Do we revert to a sort of winter time, a standard time arrangement all year round, or do we go into year-round daylight savings time? So when we asked, so we did a study on public perceptions in Ireland, and obviously geographical context matters, or as geopolitical context matter. And what we found is about 60% of people wanted to get rid of the clock change, because that's not terribly surprising. But about 60% of the people then expressed a preference for permanent DST. So sort of so here's the crux of the matter for us as chronobiologists, which is essentially not to make things worse in an attempt to make things better. So most chronobiologists would probably like to get rid of the twice yearly clock change. We think it's disruptive. And if you were to build a system from the ground up now, if it was a greenfield situation, as we say, you wouldn't start with that arrangement. But it is the arrangement we have for historical reasons. The question then is, if we abandon the clock change, do we run the risk of making things worse by going into a permanent daylight savings time?
So basically what Andrew found is that, yes, the majority of people who filled in the survey in Ireland did want to get rid of the clock change. But when they were asked which system they would adopt or they would prefer to adopt, they then said that they would want DST throughout the year, which is exactly the opposite of what most chronobiologists want. because of the increased social jet lag that we talked about earlier. Andrew and his team actually also asked people a reason for their choice, so why they would want DST throughout the year or standard time throughout the year. And for the people who said they would prefer to have DST throughout the year, this was the answer.
So we asked people about their reasoning. So people who wanted DST, the most commonly endorsed reason for that was more evening, sort of a leisure amenity. So more evening light, maybe better chance to socialize or whatever. When we asked them why they wanted to get rid of the clock change, the most commonly endorsed reason was health. So that indicates that we've been partly successful in communicating that getting rid of the clock change may be beneficial for human health, but it does highlight then we have more work to do in persuading people that that's okay, but if we adopt a permanent DST type solution, then actually there's all these potential downsides. And we're just shifting, we're stealing light from the morning potentially to put it in the evening. And in winter, when we have a deficit of sunlight in general, that's probably not a great idea.
There's another thing about these answers and how people feel about DST and standard time in general, which is that wording is quite crucial, and also how we conceptualize these times. So summertime, wintertime, also, of course, plays a role in how we feel about them.
If I say to you, look, let's adopt all year round daylight savings time, summertime, well, who doesn't want more summertime? Who wants more wintertime and less summertime? So, of course, you say, so semantics are important.
The point about wording is also important when we look at the result of the European Union survey on abolishing the clock change that Andrew mentioned earlier. Other than the fact that less than 1% of the EU's population actually responded, and 75% of these individuals were from Germany, so really not representative, the survey used the words summertime and wintertime to refer to daylight saving time and standard time, which, as we said earlier, definitely have a positive or a negative connotation. The problem is, though, that in German, for example, there is no other official name for DST. Summertime is Sommerzeit, and this is the one and only official term, which of course complicates things when it comes to accurate wording.
But also, here's the thing. I have never experienced daylight savings time in the winter. In my lifetime, that's never happened. So if I'm trying to sort of forecast what that might be like, I'm forecasting into a scenario that I don't have direct experience of. And therefore, I may be prone to sort of psychological biases. So I may overestimate the benefit and underestimate the cost of the new arrangement. And this is something in behavioral economics is known as errors of hedonic forecasting, where people in general tend to overestimate the benefit of a scenario in which they have not yet experienced it and underestimate the cost. So in trying to sort of do the mental contortions, we tend to focus on the benefits that will be there and to discount the costs. So we think that's probably important, and we think just the general semantics. And people don't think about this, and this isn't being critical of the public at all, but people don't think deeply about this, and you hear people say, well, DST gives us more sunlight. Well, of course it doesn't. We have the same amount of sunlight in the 24 hours than we have anywhere. DST, or standard time does, is it regulates how we structure our activity as a society around those hours of sunlight. But it doesn't make there be an hour more sunlight. It just changes how we behave or when we behave relative to that sunlight. Yeah. So there's lots of, when you sort of try to unpack it, there's lots of sort of different things that go on.
It's worth mentioning that, in fact, if we did have DST all year round, mornings in the winter would be very dark, which is not necessarily something that a lot of people would like. Also, there are a couple of countries which have adopted DST at some point in history, including the UK, the US, and Russia. All of the countries abandoned permanent DST at some point. Now, stepping back from thinking about public opinion, there's another thing that Andrew mentioned during our chat that I found really interesting, which is basically asking ourselves as chronobiologists whether this is really the battle that we want to fight.
I have another thought on this as well, which is, as a community, is this really the battle we want to fight? Which I'm not convinced it is the most pressing topic in sort of sleep, chronobiology, public health. I think there's issues of bigger magnitude and bigger impact, such as working time, shift work, the school start time debate. I think those things potentially would have a bigger impact, maybe not on as many people. And this is where because the clock change impacts everyone in those countries that do the clock change. But I'm not sure this is the hill I would choose to die on for chronobiology and sleep medicine. So, yeah, I'm not, because I think if we look at the evidence, and if I was a policymaker, and someone came to me and said, look, let's do away with the clock changes. They're harmful to human health, all this. Obviously, there's a cost to making the change. There's societal disruption. So there's a cost. So I would want someone to quantify for me, well, how many lives are we going to save if we do this? What's our healthcare savings going to be like? What are the physical and mental health benefits? And I don't really see in the epidemiology strong imperatives that would drive me to say, okay, well, there will be definite and substantial benefits to doing this. Now, maybe that evidence just isn't there because the question is difficult. And maybe we can only really address that question by doing it, but there are big costs to it. So my suspicion is that we could talk in 10 years' time and we'll still be in the same spot and we'll still be talking around the same issues and basically nothing will have happened.
So I'm going to leave you with this provoking thought from Andrew, just to wrap up the episode. But before we finish, I'm going to give you a little summary of what we have talked about today. So we discussed that the immediate effects of the clock change from standard time to DST in the spring, like sleep loss, more accidents, are definitely there. But the long-term consequences of DST, particularly social jet lag, may be even more concerning, according to scientists. Though we also said that measuring DST's impact is very difficult because factors like geography, so where you live in the world, seasonal changes, and weather all play a role. When speaking to Sara about the effect of DST on road traffic accidents, we concluded that actually research findings are very mixed and conflicting, so we don't really have evidence for the impact of DST on road accidents. In terms of public opinion, when we spoke to Andrew, the public largely supports abolishing clock changes, or at least it did in his study in Ireland. But paradoxically, it preferred a system that scientists say could be worse for our health, and that is DST across the whole year. Ultimately, this is a very complex issue that balances science, policy, and public opinion. As the debate continues, however, it's clear that better communication between scientists and the public is really key to making informed decisions about time policy. And with this, enjoy the time change on Sunday. Hope you're not feeling too sleepy on the Monday, and see you next time. The next episode is coming out on April 29. You have been listening to Light O'Clock. This podcast is produced by me, Caro Guidolin. The podcast team includes many of my amazingly supportive colleagues and lab members. Manuel Spitzchen does the scientific fact-checking, and music, mix, and sound design are done by Ingo Bednarek. Show notes and additional resources are created by Maidel Fernandez Alonso and myself. Our social media team includes Lucien Bickerstaff, Nilufar Tabande, and Zara Alkaf. And Anna Magdalena Billa is our test listener. Light O'Clock is a podcast produced by the Translational Sensory and Circadian Neuroscience Unit, and we are supported by the Circadian Mental Health Network, the Viscom Prize from the Deutsche Gesellschaft für Psychologie and the Deutsche Gesellschaft für Psychophysiologie und ihre Anwendung, the Max Planck Society and the Max Planck Institute for Biological Cybernetics, and the Technical University of Munich.